Assalamualaikum. Hi guys, in this video we are going to describe the variation of ionic radii of isoelectronic species in period 3. So if you take a look here, I got the graph for ionic radii based on species in period 3. We are going to divide them into 3 parts. So the first part, I'm going to explain based on radii of positive ions from Na plus to Si4 plus. After that, I will explain about the fluctuation between Si4 plus and P3 minus. And last but not least, I will explain the trend for P3 minus to Cl minus. So this is how we are going to divide them into 3 parts. So how to start the explanation? No matter what, you have to write the electronic configuration. So I will put all my respective ion from positive charge until ions with negative charge. And after that, write the electronic configuration. Next, I will calculate their number of electrons and determine ZEF. Why? Because all of them are in the same period. So I taught you in the previous video, if we got species with the same n value, factor that we are going to take a look at will be effective nuclear charge. So that is why I calculate ZEF here. You can see the value based on this trend. Hence, you got the ionic radii based on the theory. So, as you see here, negative charge species will have larger size compared to positive charge species. So we are going to explain one by one about this trend. I will divide them into 3 parts. Positive charge first, and then the fluctuation between Si4 plus and P3 minus here, and last part between negative charge species. So let's go to the first part. We got the positive ions from Na plus to Si4 plus. So in this case, I got Na plus with ZEF positive 9 compared to Si4 plus, we have ZEF value positive 12. So more ZEF means that the size becomes more smaller. So you can take a look here, all of them are in the same period, and you can see the ZEF value increasing from Na plus to Si4 plus. So of course, the acronym that we are going to use based on layout, PISAs. Now, the first point that you have to write down, first thing first, before you write about PISAs, you need to mention their electronic configuration that are same. So you need to mention they are isoelectronic with EC 1s2, 2s2, 2p6. Ini memberikan satu markah kepada your explanation. So a bit additional point dekat sini. Next, we will continue with the proton number. So proton number increases from Na plus to Si4 plus. You can see from here, 11 proton number until 14 proton number. Then ZEF also increases. Next, the attraction between nucleus and valence electron becomes stronger. So electrons are pulled closer to the nucleus, hence ionic radius decreases from Na plus to Si4 plus. So in order for me to arrange this species, I will start with Na plus much more greater than Mg2 plus, greater than Al3 plus, greater than Si4 plus. So Si4 plus has the smallest ionic radius. So within isoelectronic species, the more positive the charge, the more smaller the species. As you see here, Si4 plus is the smallest one. Next, we go for second part, where I'm going to explain about fluctuation between Si4 plus and P3 minus. So you can see that there is a sudden increase based on positive charge to negative charge. So why is this happening? First thing first, write the electronic configuration for P3 minus and Si4 plus first. So you got the P3 minus, and the highest n value is n equals to 3. For Si4+, the highest n value is n equals to 2. So you can see that these two values are different. So when it is different n value, we are going to use factor shielding effect. So the layout for NSAS will be applied in this explanation. So I pick my subject. For example, I put my subject is Si4+. So Si4+ has less shell than P3-. Hence, its shielding effect is smaller than P3-. Then, the attraction between nucleus and valence electron is stronger in Si4+, because it has less inner shell electrons to shield the valence electron closer to the nucleus. Therefore, ionic radius for Si4+ is smaller than P3-. So this is how you want to explain based on the sudden increase for Si4+ and P3-. Let's go to the last part. I want to explain about the negative ions based on P3- until Cl-. You can see that they are all share the same electronic configuration. So we need to write the first point. They are isoelectronic with EC 1s2, 2s2, 2p6, 3s2, 3p6. And after that, we talk about based on layout pizzas, because in this case, n value for them are the same, n equals to 3. So they got the same n value, pizzas layout. The next point, we talk about proton number increases from P3- 15 proton number until Cl- 17 proton number. So ZEF also increases. The nucleus attraction with that valence electron getting stronger. Electrons are pulled closer to the nucleus. Hence, ionic radius decreases from P3- to Cl-. So in this case, the most largest species will be P3- and the smallest one will be Cl-. As I mentioned before, within isoelectronic species, the more negative the charge, the larger the species. As you see from here, P holds the most negative charge compared to Cl. So that is why you got this trend as the variation in ionic radii of isoelectronic species, specifically for period 2 and period 3. So you can see from this trend, I will explain based on pizzas, and then between these two, I will explain based on NSAS, and from these three, I will explain same with pizzas. So I hope you are clear how to describe the variation based on their respective isoelectronic species. First thing first, no matter what, write the electronic configuration first and follow the layout that you need to use. So by now, awak boleh nampak betapa pentingnya kita untuk tahu menggunakan layout sama ada pizzas ataupun NSAS ketika menjawab soalan. So that's it for this video. I will see you in the next one. Bye!